Okay, hopefully the microphone is still working from the last one. The second section that you're going to look at today is section 7 on how to simulate compound events. Um, in this section, we look at ways to simulate a probability experiment and find experimental probabilities um, for things that maybe you can't physically do, but we could set up something that has the same probabilities and be able to do those in real life. So a simulation, this is found on page 412 of your book, is just a model of a real world situation that can be used to find probabilities. So fill this out on your vocab sheet. Maybe pause, take a second to put that away. Um, on page 412, they have a couple of examples of using a spinner to help simulate a real world situation. So in this situation, we've got a weather forecast showing that on Thursday there's a 40% chance of rain. And on Friday, also 40%. And Saturday, 40% chance of rain. This gal wants to go for a hike, but she doesn't want to do it if it's raining. So based on this, should she postpone the hike? So if we want to try to simulate this, like how likely is it that it's going to rain all 3 days or even 2 days? Then we can do a probability simulation. And we do that by creating something that's going to exhibit the same probabilities, the same percentages that we're seeing with the rain versus no rain. So in this scenario, our two options on any of these days is that it's going to rain or it's not going to rain. Okay, the probability that it rains is 40%. We want to try to write that as a fraction. 40% as a fraction, we could go with 4 out of 10 or 2/5. Okay, if the probability that it rains is 2/5, then the probability that it doesn't rain would be 3/5. It would have to make up the rest of that fraction to make a whole. So one thing you can do here, spinners are really nice because we can design them however we want. And how we want to divide this, we have a circle spinner. The denominator is going to tell me how many equal parts I need. We're going to use our imaginations and pretend that these are all the same size. That's not awful, but it's not great. So these 5 sections represent our denominators. 2 of them I'm going to label as rain, because that 2 out of the 5 is 40% of the spinner represents rain. The other ones could be no rain. The order that we put those in doesn't matter. I could have the rains next to each other, or I could kind of space these out like that. It doesn't matter. The probability of your spinner landing on each space is exactly the same because they are theoretically all the same size. Again, using your imaginations. So this spinner is our simulation. So then if this gal wants to decide whether she should go hiking or not, if it's going to rain, she would do several trials. So in the book, they have 5 trials. of her spinning the spinner 3 times to represent. The first spin would represent if it's going to rain on Thursday. The second spin would represent if it rains on Friday. The third spin represents if it rains on Saturday. So she spins it and she gets rain, no rain, no rain on the first trial. No rain, rain, no rain. Rain, rain, no rain. And this one, we got none all the way across. And rain, no rain, no rain. So based on this, on her doing the simulation, you'll notice in none of these scenarios does it rain on all 3 days. So the likelihood of it raining all 3 days is pretty low. We could probably expect it to be almost zero. And this is by no means, 100% accurate. It might rain all 3 days. If it's Montana, it might snow all 3 days. We don't really know. But this would give her a pretty good idea that on at least one day out of the 3, she would have no rain. So this would tell us that she should go on this hike. She shouldn't postpone it because at least one of the days during that 3-day weekend or whatever is going to not be rainy. So we can look at this and say the likelihood of it raining all 3 days is very, very low. So she should go on her hike. If you are modeling something that has like 2 different outcomes that are equally likely, say I can't even come up with an example. The one in the book is using a 50% chance that the volleyball team will win any one of its 4 remaining games that they have in this year. So the simulation in the book is showing using a spinner that's divided into 2 parts. This one should be better. And they label it as 1 and 2. I would label it as win and loss. So if we spin the spinner 4 times in a row, that would simulate the 4 games. Okay, so in one trial, if I spin this, and I got win, loss, loss, win. In that trial, they win half the games, they lose half the games. So we want to know if we can come up with the probability that the team will win exactly 2 of the last 4 games. And it doesn't matter which 2, if they win the first and last, the first 2, the last 2, any outcome that has 2 wins, 2 losses. Okay, and they'll give you here's all the options, or here's all the outcomes of these different simulations. In the book, they've got all these different options, and I got bells ringing all over the place over here. Let's just look at 5. If we do 5 simulations of this. Okay, out of these 5 trials, how many of them show winning exactly 2 games? Well, we have this one, and this one. So the probability of having 2 wins based on our simulation would be 3 out of 5. So there's about a 60% chance that they'd win half of their games based on our experiment. The wording of these is going to be really important. In this scenario, I was looking at winning exactly 2 games. They might also say something like win at least 2 games. Okay, at least 2 wins is also going to include 3 wins. Okay, 3 is at least 2. So in that case, the probability of winning at least 2 games goes up. Now it's 4 out of 5. Okay, so we can set up a simulation. Spinners are really handy because you can divide them into however many outcomes you need. Um, a simulation like this one, where we have a 50% chance of each thing, this could also be done using a coin toss because the theoretical probability of getting heads or tails is also 50%. So if you said, heads equals a win, tails equals a loss, you could flip this coin 4 times and keep track of the outcomes that way as well.